So if you look on our website, uh, there are already a bunch of the videos up there. I don't think they cover using a graphing calculator to do any of this stuff. And I will have to make a special YouTube site to upload all the class videos. But let's say real quick that we need to graph something simple like say 7x greater than, I don't know, let's say, let's make it easy and say 21. If you do the math, what's the first step that you're going to have or do when you want to try to figure this one out? Divide by 7. 21 divided by 7 is, do we need a graphing calculator for that? No. But just so that we can say or show how easy this is, at least hopefully. If you go and you hit the y equals button up in the upper right-hand corner here, or upper left-hand corner, bring you to this. I have no idea what's actually left from previous classes. So you can see here that I've already got a couple of equations on here. I can hit the arrow over key, then hit clear to delete it. And then down here, I'm going to hit the clear button again. So what we're going to do is let's try to graph 7x. Now that I've got everything cleared out, one of the cool things, some of you in the back might not be able to see it. One of the cool things is to, if you look down here, you can see all the buttons that I'm pushing. So if you missed something, I guess for you in the back, if you have binoculars, you can see what's going on up there. But in order to get 7x, I have to type in 7 and then come up here and just hit X. So simple enough. And then up here, if this works right, I should be able to put in just 21. And once I've got that, I should be able to hit the graph button. And you can see I've got a line right here, but we can't really see much of anything else. So what this is telling me is basically this is 0, this is 1, this is 2. So 21 is, or 7x equals 21, or 7x greater than 21 is definitely out of the view that we have here. So I have to go to window. And you can see X min, X max. Shade resolution, don't worry about that. But I'm going to make this say negate 10 to 10. X scale, just leave it as is. Y min, this would be negate 10. And Y max, because we're looking at 21 here, if I put plus 10, it's not going to help. If I put 15 or 20, it's still not going to help. So let's go with 25. So now that I've got that, this thing right here where it says like little triangle X, if you get into physics, chemistry, engineering, you're going to see a lot of these little triangles that just means change. So basically every time, once we get this graph up, every time you hit the over button, it's going to change 0.07575757575 units. So if you need to go up to positive 21, it's going to take you for freaking ever. So now that I've got this, let's try this again. And what is the problem that we have? 7x greater than 21. The red line here is 21. So anything above it is going to be greater, right? So we see that it crosses right about here, bring that down. You see that it's gonna be about. Okay. So if you're trying to graph some of these other functions that we had in the last section, you can do basically what we just did. One side of what you have written down, make that say y1. The other side, make that y2 and graph it and see what's going to come up. That way you have an idea about where all these things or where the right answer is going to be. For exam purposes, if you were given this problem and you just said x equals 3 because that looks like what it should be, that's when you like 2 points out of 5. Going through dividing both sides by 7 to show that x has to be greater than 3, and then saying x greater than 3, that's going to get you all the points. Okay. So this is just a way of trying to figure out about what should the answer be. Because if we look at this really quickly, let's say instead of a 21, I make that 20. We graph that. Does it look like it changed all that much as far as where we cross over? I mean, if you drag that down, you can almost make yourself believe that it's going to be again. Is it? 20 divided by 7, 2.6. So it's actually going to cross over data here. So you can't use this to get yourself the exact answer that you need. You can use these ideas to give you an idea about what the answer should be. So again, if you're trying to solve a problem like this and you came up with x is negative 52. That looks like positive 3-ish to me. Is positive 2.6 repeating 3-ish? Yeah. So when it comes exam time, this is a method for trying to get what the right answer is, or an idea about it. When I taught this class last term, I think on every single exam that the students had, most of the students missed 20 to 30 points on the exam because they didn't bother to graph it first. They just went ahead and said, you know what, I'm just gonna solve it using math. I don't have time to graph it. They got numbers. The numbers were way off. And if you know what the answer is supposed to be, and then you look at where they went wrong, it's really easy to figure out where they screwed something up. And what was the thing that they most likely screwed up? Negative times a negative is a what? So when you're dealing with all of these, make sure that you try to graph these when you can. Can you graph every problem? No. Can you at least graph a lot of these problems to help you out? Yeah. And I will say, based on the students I had last year, I think there were only 3 that didn't need the help that I'm trying to show you here. But of those 3, literally all 3 of them took AP Calc in high school. And then they were taking this class because reasons that I don't understand anyway. So anyway, we get to cover 2.6 and 2.7 today. And this is always part of the fun stuff. So if we go to 2.6, we're going to be dealing with what they're calling compound inequalities. Couple practice problems here, but most of what these problems are going to be like these, meaning what? There are actually going to be several different problems that we need to try to solve. So looking at like the example problem here, they have already gone out and done this entire problem. But we do pretty much the same thing we did before. We want to get x by itself over here. We start off with one side. So add 3 to both sides. So they completely skipped it here. Add 3 here, and 9 plus 3 is 12. -3 plus 3 is 0. So we have this 6x less than 12. Divide both sides by 6. And we get x is less than 2. Again, with a problem like this, if you're looking at it and let's say you're kind of freaking out when you look at a problem, is that happening to anyone right now? You're looking and go, whoa, wait, what, huh? So again, want to make sure that I've got all of this stuff here. So we can actually go in and try to look at this to give us an idea of what we should be getting. So again, if I want to graph this, I can go to y. And I've got 6x minus 3 on one side. So I'm going to clear this out. Come down here to 6. Up here to x. And then minus 3. And in this next spot, because I've just got 9, I can type in 9 and then delete. If you hit 9 and then clear, it deletes or gets rid of everything. So you have to put the 9 back in there. If there's just one little bit that you want to get rid of, that's what the delete button is for, okay? So if you accidentally typed in 99, you can go back one space, hit delete, and it's going to be fine. Now that we've got this thing set up, I can graph it. And we want 6x minus 3. So that's the blue line to be less than 9. So you can look here, where's the blue line below the red line? Seems to be like right in that area, right? So again, this isn't going to be the 100% correct answer. It's just giving you an idea of what you should be getting. So we know that there's going to be something in here that deals with the x and 2. And then we do the same thing for the other side of the problem. And when you look at these, this is saying that x is greater than or equal to -3, but x also has to be less than -2. So we already figured out how we get the x is less than 2 from. Again, plug this into the calculator, let the calculator do everything. We're looking for x greater than the red line if we redo both of the problems. Now, the trick here, you can see here, it says graph the solution and write the solution in interval notation. So with this one, since we've already got it, let's see if they've already figured it out here. So since it's the example problem, x less than 2 is the top one. X is greater than -3 is the bottom one. And because we want values of x that satisfy both equations, it's going to be the overlap that we have. So going back to, what is it, Math 072? Any of you take that here? Okay. It's actually the other class that I'm teaching. If we're thinking about this in terms of mathematics, this is the intercept of equation 1 and equation 2. If you remember what that means, awesome. If you don't, the intercept is essentially where the things overlap. That's all that we really care about. When you look at the interval notation down here, Again, around the bracket, no equal sign. If there is an equal sign, then we need to have the square bracket. There will be some of these problems that we look at where there is no answer. So we will deal with that when we get there. So looking at, do you guys want to try 121 or 122? Or do they look equally horrible to you? Probably equally horrible. So again, let's look at 121. And get this out of the way. Move this over. So we've got our two equations here. So I can actually look at this. Go to y equals. This is going to be 4x. I've already got the x there. I've already got the minus there. And 7. Already got the 9 there. For here, type in 5 times x. And then plus 8. So we get this part here. And then this has to be greater than or equal to 3. So we can put 3 here. Now this is going to look a bit like a mess. The top boundary is going to be the red line. The bottom boundary is going to be the pink line. And just looking at how this is set up, we're going to want that overlap again. Okay. So we can go ahead and graph these. And having it in color, doesn't that make it so much easier? So we know the blue line is 4x minus 7. The black line is 5x plus 8. We've got our two boundaries here. The red line here is for the blue. And it's saying we want everything that is less than 9. So basically starting here, we can come down. So it looks like it's going to be about 4. Is it going to be exactly 4, about 4? Well, if you do the math, you'll figure it out real quickly. And then for the other one, we look at the boundary here and we want everything above that line. So where does it look like it crosses? So that's 0. That's what? -1. So without doing any math at all, with these problems, I'm going to write them down real quick. For the first one, we get x is approximately 4. For the second one, again, based on what we have there, we have x is approximately -1. Is it really? Well, we'll find out in a moment. Well, like I said, this gives us an idea about what the answer should be. So the squiggly lines that are kind of parallel to each other, that just means approximate. Since I don't know what it is yet, because we didn't do the math yet, it looks like it's about 4 and it looks like it's about -1. So let's see what happens. So here, so the first step, we want to get x by itself. So the -7, move it to the other side. So we're going to be adding 9 plus 7, 16. And then -7 plus 7, that cancels out. Divide both sides by 4. So by looking at the graph, I said it looks like it's about 4. So yeah, it's about 4. Not too difficult yet, is it? On the next one, we need to get x by itself, so move the whole number to the other side. 3 minus 8, going to be -5. Divide both sides by 5. So by looking at the graph, I said it was going to be about -1. Yeah. Just make, yeah. On these, because as they are written out, if I had a -5 here, then we would have to flip the sign. So if we have a negative value out in front of the x here, then we would flip it. So looking at what we have, we now know that the problem that we're dealing with at the low end, it's going to be -1. At the high end, it's going to be 4. Since there's no equal sign here, rounded brackets, because there is an equal sign here, square brackets. So does that make trying to solve some of these problems so much easier? Look at a picture and interpret a picture. How many of you are going to totally not do that on the exams and just, hey, I'm going to math this? Yeah. 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 So we can think of this as, say, a number line. Uh, 0. The negative stuff is always, or the smaller stuff is always going to be on the left. Larger stuff is always going to be on the right. So at least in Western culture, that's how we do it. If anyone here is from one of the Eastern cultures, I have no idea how you do it there. But that's going to be, or the way that I've got it there, that's going to be the correct answer for this class. Okay. So with these, again, does this particular problem look a whole lot worse than what we had before? Well, before it was just going to be 2x plus 5. Now we're saying 3 times this whole thing. So it is a step up. Because in math, as we all should know by now, things get worse, right? So with these, again, what's our first step going to be? We want to get the x's by themselves. And if you look at what they did here, they distributed the 3. And then what you do at the end, you basically have to undistribute the 3. Does anybody want to do something and have to undo it immediately? So you can see what the textbook did there. And what I'm about to do works on both of these, but just to give you an idea about how you can solve them. And this is, of course, assuming you don't want to do extra work. So just making sure I've got the right thing on there. So I'll actually do this the way the book did. but do it in every step and then do it the way that I would do it. So their first step, distribute these. 3 times 2, 6x, plus 3 times 5 is 15, less than or equal to 18. The next step, subtract 15 from both sides. That's going to give us 6x less than or equal to 18 minus 15. 3. Then divide both sides by 6. 3 halves or 3/6, which is going to give you 1/2 eventually. Or divide everything by 3. 18 divided by 3. Subtract 5. 6 minus 5 is 1. Divide both sides by 2. Either way works. Is anyone here? And no, I asked this last time. Is anyone here a computer programming major or minor? So when you get into some of your higher level math or computer science classes, and then for everyone else here, taking any math class, there are always going to be a bunch of ways you can try to get the right answer. But you usually want to use the method that use the amount of steps. So if we look at this, going from here to here, you have to do 1 math thing, 2 math things, move the 15 over, that's 3 math things, divide each side by 6, that's 4 math things to get you that far, reduce that 5 steps. Here, dividing both sides by 3, 3 cancels 3, so that's 1. 18 divided by 3, that's going to be 2 steps. -5 goes over 3 steps. Divide by 2, 4 steps. Would you rather do 4 steps or 5 steps on every problem on your exam? So and like I said too, when it comes time to the exam, I don't care how you get the right answer, as long as you do it by yourself and not stealing it from a neighbor. But I will say one of the big issues that I've seen with a lot of students taking pretty much any type of math class is you will have one way of doing it. And when I was tutoring, we do it one way where it literally takes up an entire page. And you have to do every single step correctly. You make one mistake in one spot, you get a wrong answer. Or you do something like we did there, and it only takes that much space. So if you're one of the students who usually finds themselves struggling to get exams done on time, if you can save a step on every single one of your problems, that's a whole lot better for you. And then 2, fewer steps, fewer chances to make a mistake. So like literally one of the things that I've seen as far as like say the difference between say an A student and a B student, the A student's gonna try to do it the least amount of steps. The least amount of steps gives you the least amount or least ability to make a mistake. The less mistakes you make, the more points you get, the less steps you do, the more time you have, right? So it's not that anyone is actually usually that bad at these things. It's just sometimes you end up getting lost doing whatever it is you're supposed to be doing. And I'll put this one into the calculator just again to show us that we already know kind of what the answer is going to be here. So if I come back up here, again, I'm going to clear this, clear this, clear this, clear this, head back up to the top here. So if you're looking at this problem on the exam and it's freaking you out, what do? I say do absolutely nothing except put it into the calculator exactly as it's written. And again, if we're going to have -6 here, if I quit, and I'll just show you what happens on here. If I type in -6, if you're following or trying to do this, don't bother doing this. So I just hit -6, now I hit enter. And let's say I want to graph that. It doesn't know what's going on. So I have to go to, and it says it doesn't understand basically that entire line. So what I have to do here is I have to use the negate. So now that I've got negate 6, graph that. There we go. And where do these lines seem to cross over? Right around 4, right? What did we get here? 4. So again, if you can learn how to graph these, and again, if you notice, I didn't do any math. I didn't distribute anything. I just put it in the way it was written. And you can essentially get yourself an answer that you can work towards. And if anyone, and like I said, with a lot of the students I've had, they will look at problems like these and try to do them all without graphing anything. And there will be some mistakes made. Not saying that any of you are going to do that, but there will be some mistakes made. So if we're looking at the original problem here, we have to find our magic values of x. And you can see here, this is saying that x has to be less than 4, or 4 is greater than x. This is saying x has to be greater than or equal to 1/2. And we're looking for values that work for both of these equations. So if we plot them on the number line like we've got here, we're looking at everything that's below those values. Well, from like 1 in, or from, well, they got it 1.5. To 4 here. Those don't work. Does anyone else see a mistake on here? Which should actually be right there. So everything from there on back is the correct answer, because we're looking at what is the overlap, what is the same between these two things. So if we're looking at the problems like these, so again, how can we do these? What's my suggestion here? I've got the 2 out in front. Let's divide both sides by 2. We'll get 3x plus 1 greater than or equal to 20 divided by 2, 10. All from there. And then same thing over here, because I've got 4 out in front, divide everything by 4, and then go from there. I'm going to skip that type of problem for the moment. So if we look at like this next set of equations, from the fraction. Anybody like fractions? In here we got -2 out in front. So looking at what the book is doing, what does the book do? It distributes y. And just looking at the way that this is set up right here, negative times a positive is going to give you a what? A negative value. Negative times a negative is gonna give you a what? Positive value. So by distributing that, you've actually got two chances to screw up that whole negative times a negative is a positive thing, and negative times a positive is a negative thing. Whereas divide both sides here by -2, and you basically just get to what? X minus 3 greater than or equal to -2. You almost get down to this point instantly. Over here, what ends up going on at the end, because you got the 1/3 out in front, you multiply everything by 3. Or you can start off and multiply everything there by 3 and get the same answer and not have to deal with fractions. So let's take a look at that one real quick. So 1/3 x minus 4, and that has to be greater than or equal to -2. So again, this does actually add an extra step in, but if you have a lot of really horrible fractions, this can actually help you out a little bit. So I multiply everything here by 3. 3 times 1/3 is going to be 1. 1 times x is x. 3 times -4 is -12. 3 times -2, -6. So we get x greater than or equal to -6 plus 12, or 12 minus 6. 6. What did the book have? So either way, again, either way is going to work. Whatever you feel more comfortable with, by all means, go ahead and do that. Okay. And when you look at the answers here, one of these is telling you everything 6 and greater. Then everything here is 1 or less. If we're looking at this problem where it says and, so again, we're looking for the overlap. Do these two lines overlap at all? Absolutely not. So it says no numbers, there are no numbers that make both inequalities true. So in a case like that, uh, again, depending on the system, depending on a lot of other things, we would actually say that is our answer. The circle with the line through it is what's called the null set. And the null set just basically means there is nothing there. And I will warn you, if you're doing the homework problems, if you have a problem like this on the exam, you say, well, there's nothing that overlaps, and you put in 0, that's wrong. Because the correct answer is there's nothing. You give me 0, you're telling me the answer is x equals 0. The answer is x, there is no value of x that works. So you have to be a bit careful about that. And again, if you're trying to figure out where all this stuff happens, put it into the calculator as written, and it will take care of itself, give you a good idea of where everything's at. So if we're looking at these next two sets of problems here, and what the textbook do is distributes and then does the math. I would just divide both sides by -3 here, divide both sides by -4, -2 divided by -4, negative divided by a negative as well. positive. So you get x minus one greater than or equal to 1/2. With both of these, multiply both sides by 5, or multiply 3 by 5, multiply 3 by 4, and you get rid of the fraction. You're going to do it eventually. You can either do it as the first step, make your problem fraction free, or you can do that as the second step. So and oddly enough, this is actually something I was just going over going over with my uh, Math 72 students earlier today. We're looking for a value of x that's between two particular values here. What does all of this mean? So I'll actually go over it with you because one of the things that actually happens with this is if you if you are a business major or pretty much a science major or even psychology, sociology, that's social work, that sort of stuff, at some point you're going to take a stats class. And let's say we're looking at something like this. Something like this. Something like that. And something like that. If I want you, or if I ask you to give me the interval notation on all of these, on here, 1 and 10, here, 1 and 10, round brackets on the top, square brackets on the bottom. For this one, because there's no equal sign here, round brackets again. Because there is an equal sign, square brackets on the other side. And then the same thing over here. Now, if we're thinking about integers, and this is where this gets a little bit tricky, and with the stats students that I have, we're actually going to be doing pretty much the same problem next week, 2 weeks, no, 3 weeks from now. So if we're talking about integers, what are the integers I can put in here? This is saying I can approach 1, but I can never touch it. So if we're talking about integers, I get to start with 2, 3, 4, 5, 6, 7, 8, 9. This says I can approach 10, but I can never reach it. So the integers I can have there look like that. Since it can equal 1 and 10 here, I get the exact same thing. But I get to put a 1 at the beginning and a 10 at the end. So again, here I can approach 1, but I can never touch it. So I start with 2, go up, and here I can say it's equal to 10. Here I'm saying it's equal to 1, and then I go up. It can approach 10, but it can never touch 10. So my highest number there is actually going to be a 9. So if I'm looking at integers, those are going to be all the different ranges that I can deal with based on what I have. If we go back to the book, so you can see we've got -4 less than or equal to 3x minus 7 less than 8. We can basically split this up or we end up splitting it up as essentially two different problems. Solve for x on that side. Solve for x on that side. We want to get x by itself. Since you've got 3x minus 7, add 7 to everything. Now we've got 3x to divide everything by 3. We end up with our value. So again, if you wanted to try to graph this, so how would we do that? I'm going to clear this out, clear this out. So at the top there, negate 4. Next one down, 3 times x minus 7. Then the next one is going to be 8. And then graph that. So we're looking at where is the red line between the blue line and black line. That looks like it's like out 1, out here, 1, 2, 3, 4. So it looks like it's about 5, right? According to the book, we get that one in the 5. So again, if you're trying to solve these problems, you can graph it. Let the graph kind of tell you what the answer is going to be, and then you can go ahead and math it, make it a lot easier on yourself. Because graphing it, once you get good at it, how long did it take me to stick everything in there? 10 seconds. Is it worth 10 seconds to you on the exam to kind of make sure you got the right answer or know what numbers you should be getting? I would think so. So if we take a look at this problem right here, again, I'm going to graph it. The top value, -5. This is going to be 4x minus 1. The high value is going to be 7. Now I can graph that. Since we're looking at where is it above the blue line and essentially below the black line. So it looks like there could be a -1 and say 1, 2. Hold on. So my best guess on this particular one, so we've got -5 less than equal to 4x minus 1 less than 7, right? And from the graph, we're getting approximately -1. It looks to me like it's about 2. So let's go ahead and solve this one. So I get to add 1 to both sides. -5 plus 1, -4. Then we've got 4x. 7 plus 1 is going to be 8. I need to get x by itself. So divide that by 4, divide that by 4, divide that by 4. -4 divided by 4, -1. 8 divided by 4 is going to be 2. So if we write the interval notation, because we've got the equal sign here, we're going to end up with something like that. So 10 seconds using the graphing calculator to get some numbers that we should be getting. When we do the math for real, we actually get those numbers. Yes. And I will say Last semester uh, when I was teaching this class, at one point, I graphed it. I knew what the answers were going to be. Then I tried to solve it on paper. I got completely different answers. What's the, what was the issue there? I put the numbers in correctly to graph them, but I switched a negative to a positive when I wrote it down. When you change numbers like that, do you change answers? Yeah. So where was the mistake? Should have been say negative 3x, but I put it as positive 3x, threw everything off. Numbers I had when I was done looked good. I didn't get any funny stuff like 52/17 or some screwy like that. They're nice whole numbers, but they're the wrong nice whole numbers. So, oops. I think what I'm trying to say there is even I screw these up. So make sure you're looking for that. So looking at what we've got uh, here next, solving problems with or. Uh, Going back to what I was literally just covering on Monday in my 072 class, this would be considered a union. With a union, what we're looking at is everything on one group, and you combine it with everything in the other group. So negative or 5 minus 3x equals or less than or equal to -1, 8 plus 2x less than or equal to 5. So again, we can plug these into a graphing calculator and figure out what's going on here. And in this particular case, if you look at what's going on here, there is no overlap between these two. And we're looking for what's on in this group over here and what's in this group over here, which is where this little U thing that we have, that just means the union. If we were to graph these, instead of looking at everything between the parallel lines, we're looking at everything outside of the parallel lines, okay? So just looking at this one right here, again, you can graph it, see what's going on. So 1 minus 2x greater than or equal to, or less than or equal to -3. And then we've got 7 plus 3x less than or equal to 4. So subtract 1 from both sides. -2x, -3 minus 1, -4. Note that we have the negative out in front of our x value here. So when we divide both sides by -2, the sign is going to flip. -4 divided by -2 is going to be 2. Up here, subtract 7. 4 minus 7 is -3. Divide both sides by 3. X is less than or equal to -3 divided by 3. So that's going to give us -1. If we plot these on numbered lines, this one here is saying what? X has to be greater than or equal to -2. So I'm going to call this 0, or sorry, +2. So I toss a 2 here. So X has to be greater than 2, greater than or equal. So built in dot, then it's going to go out this way. Here we've got -1. And this is saying x has to be less than or equal to -1. So we've got that whole thing and everything behind us. And we want to know what values of x work for either this equation or this equation. This seems to go all the way out to -infinity. And we combine that. Oops. See, even I can screw these things up from time to time. Because we've got the equal sign, square brackets. And if we were to graph that, basically the equations that we put in here, this one's going to be have a negative slope like that. This one's going to have a positive slope. And then when we plug in -3 and 4, we're going to look at everything on the outside of that. And then, of course, eventually you're going to get to problems like these. So again, do we like fractions? Not really. So if it makes you feel better, multiply everything here by 3, multiply everything over here by 4, and you can importantly solve it. You're going to get the same answer. You can see what's going on here. In here, if you notice what's going on, we want everything from the thick black line that we have up here, and we're going to combine it with everything from the thick, what you call that, Robin's link. Notice that there is some overlap. So this is the next step in these types of problems. Because there is overlap, we want values of x that solve either or of those problems. It says down here, the solution covers all real numbers. So if we put that into interval notation, -infinity to +infinity. So again, we could try to graph these and see what's actually going to be going on there. And it's going to be a bit of a mess. So if you look at, let's say 131. So 3/5 x -7 less than or equal to -1, and 1/3 x. It's 1/3 times x plus 6 greater than or equal to -2. So I'll flip this over so you can actually see what I'm doing. So for this one, if I wanted to, I could multiply everything by 5 and carry on from there. Here, I can try to distribute the 1/3 to everything, make these fractions or put fractions everywhere. Or I can just come out and say, I hate fractions. Multiply everything by 3. -2 times 3 is -6. -6 minus 6, -12. Here, just because of what I've got here, I could multiply everything by 5, or I could keep it as it is and work with it. For this one, I'm actually going to try to work with it first. So -1 plus 7, that's going to be a 6. And now, just because of how this is set up, I need to get rid of the 3/5. So if you know what's coming next, awesome. Basically, I'm going to multiply everything by 5/3. So I'm going to take that fraction and just flip it upside down. But it'll make it hopefully a little bit easier on everyone. I'm going to multiply everything by 5 initially. So 5 times 3 is 15. 15 divided by 5 is 3. 5 times 6 is going to be 30. Still need to get x by itself. So divide everything by 3. 30 divided by 3 is going to be 10. So if I do have the number line for this, if that's 0, I'm going to say out here is 10. This is telling me x has to be less than or equal to 10. Out here, again, that's going to be 0. That's going to be a -12. And this is telling me that x has to be greater than or equal to -12. So I can have something like that. So just so we have some practice with it as well, and call this equation A. I'm going to call this equation B. If we're looking at A or B, we try to figure out what the interval notation is going to be. It has to be a solution for both, or that works in A or works in B. We have this overlap. So our answer here is just basically going to be -infinity to +infinity. If I say A and B, and just so we're clear, this or is the union and is the intersection. So for this one, all values from -12 to +10 work. So the top one is just saying it has to work for one of them. I don't care which. The bottom one is saying it has to work for both of them. So if you think fractions are horrible, check out these when you've got a couple of decimals here. But it's using the same types of ideas. So here it says solve absolute value inequalities. Does everyone remember what an absolute value is? If you have, so you can see right here, it says -5 is 5 units from 0. So absolute value of -5 is going to equal 5. 5 is also 5 units from 0. So absolute value of +5 is also going to be 5. So basically what happens is anything that's in these absolute values here is always going to end up being a positive number, no matter what value you actually calculate, which is kind of annoying. So if we look at the example problems that we've got here, so the absolute value of x is 8. If I put a +8 in there, absolute value of +8 is 8. I put a -8 in there, the absolute value of -8 is also going to be 8. is where this plus and minus thing comes from. Um, is there such a thing as positive zero, negative zero? So plug in zero there. Absolute value is 0, 0. Here, like I said, anything that you put in here has to be positive. So can I get a negative 6 when the number has to be positive? So they're actually trying to trick you on this particular problem. So you can see here, and what we're asking is what value can we stick in for y that when you take the absolute value of it, you get a negative 6. That's not going to happen. On the other hand, and it's something that's going to come up in here anyway, if I can actually put a negative on the outside, and now I can say what values of 6 can I stick in there that will give me negative 6. If I put in positive 6, absolute value of positive 6 is 6. The negative is out in front. It's going to give me negatives. I can put in negative 6 in here. The absolute value of negative 6 is going to be 6. I've got the negative out in front, so I've got the negative there. If you want to look at it as, say, distributing the negative, so multiply everything by -1, or you can divide everything by -1. This whole thing eventually becomes that. So again, what values of x can I stick in here that'll give me a +2, +2 or -2? What values of y can I stick in here that will give me a -4? There are none. And this isn't even an issue of, say, complex numbers or anything like that. There just literally is nothing you can stick in there to give you the answer here. And we can actually try to graph these. So we can try to get an idea about what these answers are going to be. So clear that, clear that, clear that. So then the question becomes, how do we get those absolute value signs on there? If you know how to grab them already, awesome. If you don't, I believe it's under math. So cubed root, x root, can see some of the other stuff that's on here. Numbers, this ABS, that's absolute solution or absolute value. So I can hit enter. And then this thing is just saying x. So I can plug in x. Down here, I want to see 2. And then go ahead and graph this. Where do the blue line and the red line intersect? Looks like -2 and +2, right? What did I say the answer to this one was going to be? -2 and +2. If we try to graph this next one, just because of the way it's set up, even though the problem says use y, I'm still going to use x. And then here I'm going to put in -4, but I have to do negate 4. I graph that. So where did the blue line and the red line intersect here? Anywhere? Since the two lines don't touch, there is no answer. So again, for this one, if I ask you, or the problem asks you for what is the solution here, it's going to be the circle with the line through it to say the null set. because there is no answer that works. What is the um the interval look like? Again, it's just going to be the null set. And I will say, based on what happened last semester, there will be one or two trick problems like that on the first test in the final exam. So if you're not thinking or you're trying to rush through these things, problems like being for both of these, you can go right past them and put down values. Both of them, what's the correct answer? There is none. So no. Yeah. Absolute value? All right. Shrink this down a little bit. Clear all this stuff out. So clear that. And then clear down here. So I've got the -4 in there already. I need absolute value of x. So in this case, I have to go to math, number, and then this ABS thing is what we need. So then I hit enter. And if you notice, the cursor is pointing in there. So like this dotted rectangle in there, that's some put some crap in here. Okay. So if I just want x, I can do that. Since I've already got this set up, I should be able to just hit graph. I'm going to get the same graph as before. And looking at the graph that we have right here, it looks a bit out of scale, but no big deal there. When we're graphing these things, and this is going to be something that comes up eventually anyways. So let's say I need the absolute value of x minus 8. So I can go to math, number, absolute value, then do x minus 8, then graph that. And looking at that, does it look like the blue line and the red line touch anywhere? So, but is it kind of hard to tell what's going on over in this area out here? So again, if we want to change the view that we've got here, we can go to window, -10 to 10. And so I've got that set for 25, make that say +10. Because we're having some issues with the X scale, -10 seems fine, but doing the +10 on X, that's where we're having an issue. So let's make this 20. Does that make it a little bit easier to see what's happening here? These aren't touching, so there is no solution here. If, and again, because this sort of stuff is going to be happening in some of the problems. Let's say we've got negative absolute value of x minus 8. And then we'll just delete that sort of stuff. So now if I graph that, where do these two things seem to overlap? So right here and right here. So right here go off. So it's this thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then right here it goes up. So 1, 2, 3, 4. So it looks like x equals 4, x equals 12 will be the solution to the problem that we were graphing, which is negative absolute value of x minus 8 equals -4. Okay. So we actually just did what, 4 or 5 different example problems in there. So even when we've got some weird problems like these, we can still graph them. So let's take a look at 137 real quick. It's the absolute value of 3x minus 5, absolute value symbol, minus 1 equals 6. So again, say this is a problem that you have on the exam. We'll try to graph these. So clear that. So I've got absolute value. So I have to go to math, absolute value. Then I've got 3 times x minus 5. I have to hit the arrow over key to say minus 1. And then for the next value here, I'm going to clear that out. And it's going to be 6. Now I can graph that. Where does it look like the red line meets the blue line? Seems like we've got 2 different spots here. And again, because of where this is happening, it might be a bit difficult to actually see what's going on. So again, we can change the window here. So x will go from, say, -10 to a +10. So does that make it a little bit easier to see what's going on? So this is telling us it looks like there's going to be a -1, and then 1, 2, 3, 4. So with this one, we know that x is going to be approximately -1 and 4. So we graphed it, we know where this is going. +1, +1. 3x minus 5 absolute value is equal to 7. If we want to get the positive root here, or one of the roots, just going to do that. Add 5 to both sides. So we get 3x equals 7 plus 5. That's going to be 12. Divide both sides by 3. Yay, we got us an answer. We graphed it, so we know that we should be getting something about 4, right? So now we went through and did it mechanically. We did all the math. We got what we needed. To get the other root, though, it's going to be the same starting point. So again, I'm going to end up with 3x minus 5 absolute value equals 7. And then what's the next step here going to be? So I have to negative value out here. Should distribute it to everything. Negative times a negative is a positive. Negative times a positive is a negative. Seven minus 5 is 2. So in this case, we get x equals -2/3. I said it should be 4 and about -1. Is -2/3 about -1? But in the ballpark. So again, power of graphing. Yay, graphing calculators, right? So here, subtract 5 from both sides, divide both sides by 2. And if you look at what they're doing, they're actually putting the negative on the other side. It's another way of trying to do it. So let's try doing it their way real quick. We'll look at this problem right here. Oh, and is anyone else sick of hearing me say, let's graph it, and negative times a negative is a, yeah, and then what's going to happen on the exams? You're not going to graph it. You're not going to remember that. Remember, negative times a negative is a positive, and all that other stuff. And then when I start writing on exams, negative times a negative is a, your answer is going to be, shut up, shut up. You told us this thousands of times. Just stop. And I am looking at 139. So if you look at what they did up here, when they got rid of the absolute value points, they put a negative in front of the 2, and then they kept a positive in front of the 2. So that's a little bit different from how I was doing it. It'll get you the same answer, but just to show you. So with both of these, this is going to be the same thing. 3 absolute value, x minus 4, absolute value equals 8 plus 4 is 12. Divide both sides by 3. Absolute value, x minus 4 equals 12 divided by 3. So that's going to be 4. So with this, x minus 4 equals 4. X minus 4 equals negative 4. Add 4 to both sides. 4 plus 4 is 8. Add 4 to both sides. Negative 4 plus 4 is 0. What do you think the next thing I'm going to say is? What do we get if we graph it? You should, if we did this correctly, we will see that the red line meets the blue, or the blue line meets the red line at about 8 and about 0. So let's see. So I want to clear that. Oops. Clear that out, clear that out. So we've got 3 times the absolute value of x minus 4, and then have to hit the arrow over button, so minus 4. Then down here, 8. So if you look right here, that's the equation that we actually started with. Let's graph it. So does it look like the lines meet at about x equals 0 and about x equals 8? Because I've got this negative 10 to 10, we know that this is 10. So it looks like it's about this line. So 10, 9, 8. Who says math is hard? Unless you don't have a graphic calculator. So far, does anyone want to dispute the fact that a graphing calculator and graphing these things might be really, really useful? So with all of these, we keep doing the same things over and over and over again. So, and just looking at thing here, it says there's no solution. So basically the same thing is going to happen here. So again, one of the reasons why I suggest that we graph these things before we try to do the math is if you just blindly go into a problem like this and you have no reference for what's actually going to happen here, you're going to solve it, and you're going to get answers, and your answers are going to be wrong. So just as an example, um, we can see here that it's saying that there is no solution. Again, if you just blindly go into this without thinking, and I'm saying this now sounding like I'm a total expert, right? What did I do the first time last year when I had this problem? I solved it and then went to graph it and then went, oh, oops, how do I backtrack that? Thankfully, it's an 8:30 class and most of the students were awake anyways. But we've got absolute value 2/3 x minus 4 absolute value plus 11 equals 3. So again, I'm going to put this into the graphing calculator. So clear that out, clear that out. The second part is going to be a 3, the stuff up on the top. So again, go to math, number, absolute value. How do I do 2/3? Basically, that's just 2 divided by 3. I need an x, so I put an x, and then say minus 4. Outside of that, plus 11. Now, a couple things can actually happen here. And to be honest, I don't know what's actually going to happen, but let's see what happens. The way that I've got this written in here, the calculator can interpret that one of two different ways. Oops. So this, the way that it's written in the calculator, 2, 3x, it might interpret it, which is what we want. It might interpret it like that, which is not what I want. A way that we can make sure that it interprets this stuff properly is if I'd actually come out here and put brackets around everything, or brackets around the 2/3. So open bracket 2 divided by 3, close bracket, then x. For right now, let's see what happens. It did a thing. Do we know what just happened here? Well, based on what we have, we've got a straight line at 3. Based on the equation that we have, what is the smallest value this side is going to take? So remember, these numbers or anything in here has to be positive. So the smallest number is 11. What's our axis set to? Negative 10 to 10. So come back here. X values are fine. Y max, let's make that 20. And now we can see the other graph. Do they touch anywhere? No. They don't touch anywhere. There is no answer. Okay. But like I said, and like I said, I did a while back, or with the first class that I had. If you're not thinking about it and you just go ahead and try to do this, so absolute value 2/3 x minus 4 absolute value plus 11 equals 3. Subtract 11, absolute value 2/3 x minus 4 absolute value equals 3 minus 11. So that's going to be a negative 8. How did we solve these? If say this is a positive 8, we'd say 2/3 x minus 4 equals whatever this is. Then we'd say 2/3 x minus 4 equals the opposite of that. And then you go and you do everything. Is that even showing? Then you go and you solve everything. What's the first step going to be with both of these? Add 4 to the other side. So 2/3 x equals 12. And we figure out what the value of x is eventually. Add 4 to both sides. -8 plus 4, -4. 2/3 x equals -4. Can you figure out what that is eventually? Yeah. So here's a problem where if you don't try to graph it first, or if you don't understand the graph that you've got, you can get numbers. They're wrong, and you just spend all this time trying to figure that out. So what is in the case of a problem like this, since we graphed it, we saw that there's no place where the two lines where the graphs met, meaning there is no value of x I can stick into the original problem to make it work the way we want. What's the answer? No solution. 0, and all with the line through it to say it's a null solution. Do you need to go through and try to do the math to prove that it's the null solution? No. Because if you try to do the math, you're going to get what we have, you're going to get answers. So again, graphing, good. Mathing, maybe not so good. And when you look at how these guys are set up here, what's the difference between what we've been doing so far and what they're doing here? They've got absolute values on both sides. So they break it down into two different solutions. So they're going to have 5x minus 1. So just get rid of the absolute values here. And keep it. For one of these, they put a negative that you have to distribute. Here, they just keep everything positive. And you get to the final answer. So if we're looking at, say 143, absolute value of 7x minus 3 equals absolute value of 3x plus 7. So again, we're going to break this down into two different problems. 7x minus 3 equals 3x plus 7, and 7x minus 3 equals negative 3x plus 7. So for here, and again, we're looking at actually both of these problems. There are a couple different ways we can do this, and this is one of those things where I've seen a lot of students, you can get the right answer, but it's going to be a page and a half to get there. How can we prevent that? I'm looking at 7x and 3x. What is the bigger number, 7 or 3? 7. So I'm keeping this here. Now I'm going to move the 3x over. Because I'm doing that, I'm going to have to move the negative 3 over. So to move the 3x over, negative 3x, 7x minus 3x is going to be 4x. To move the negative 3 to the other side, I have to add 3 to both sides. 7 plus 3 is going to give me 10. Divide up each side by 4. Sorry about that. Try to zoom out a little bit. So we've got our first value here. Over here, first step is going to be to distribute the negativity. Isn't that usually my job, or is it my job to distribute the insomnia or the sleeping pills that put you all in a daze? One or the other? Okay, whatever. So negative 3x minus 7. Again, I'm looking at this. Which one of these is a larger value, 7 or negative 3? I'm saying 7. So I'm going to add 3x, both sides. That means I have to move this to the other side. Negative 7 plus 3. Divide both sides by 10. And because I've been saying this graph it and math it thing, let's graph it just so we can see what these look like. I'm going to set the window back to negative 10 to 10. We'll see how well that actually works out. So clearing both sides. Math, we want absolute value. And on one side, we've got absolute value of 7x minus 3. And then up here, we can have the absolute value of 3x plus 7. Let's graph these and see what happens. So we can see one spot where these two equations meet. Right about there. We can see that it's a negative value, but it doesn't make it all the way to 1. So we know that the value should be somewhere between 0 and negative 1. What did I figure out? Figured out to be negative 2/5. Is negative 2/5 between 0 and negative 1? Yeah. What about the other one? We don't know. We can't tell. So go back and change the window. And let's say change the max here to 20. See what that looks like. So now we can figure out what the other value is. It's right about here. Looks like it might be somewhere between 2 and 3 and positive. Is 5/2 between 2 and 3. 2.5 between 2 and 3. So again, graph it, see what you should be getting, then go back and do the math. And shouldn't say this on on camera, but if you know how to fake the math really nicely and you get the right answer, most of the time your math professors aren't going to really look at how you got the right answer. It's when you get the wrong answer that we're really interested. Just saying. And sadly, and I keep telling you all about, okay, graph it. And in one of my math classes, all the students or all the other students were using graphing calculators like you had. This is a graduate level math class. I was trying to do everything the way the professor said, had to do it all by hand, by hand. All the other students got the right answer using the graphing calculator, then went back and faked the math so it looked good. They ended up getting A's on exams because stuff I did was say 100 different problems or 100 different steps. You screw up one, you've screwed up everything and you're done. So we can combine these to come up with where is it greater than a certain value. If we're looking, just to make it a little bit easier, looking at what we have here, where is the equation that was plotted in red greater than the equation that was plotted in green? Here, basically all the way back. And here, all the way forward. Okay. between these two numbers, the red line is definitely the blue line, right? Easy enough to see. So we can try to graph these, or we can try to solve the math behind it. We kind of already did, but that's actually what this next section is in here. Try to find where the two equations meet. And here we're looking at absolute value of x is less than 7. So just looking at what we've got here, any value between -7 and +7 without touching 7 is going to be the correct answer, which is why we have the rounded numbers here. And then you can come back and you can do a problem like this and try and figure out where is this whole thing less than or equal to 4. Again, because we've got the equal sign there, we've got to have the square brackets. So I'm going to give you problem 147 to work on. And what I'm interested in here is what are the values of x that will actually make that true. So what should we do? First thing is graph it, see where it touches, and then keep in mind that the equation or we're going to have one basically straight line at 5. We want to know where the other line is below that. Okay. So if I'll try to do the math, just go ahead and graph this. And then put it on a sheet of paper, and you can hand that in. And just so you can get an idea about what's actually going to be happening here. I want you to solve 147. I'm going to do 148. So in this case, I get 2x. Well, probably to solve your problem, that's the wrong one. 4x minus 5. And then down here, got 3. Got to clear that out, hit 3. Now I can graph that. And I can look at this graph. I can get an idea that around, say, 2, maybe at a half. This blue line is below the red line. That's all I'm looking for. But you have to use the right equation. Sorry? No, just you graph the function and tell me what it looks like it is approximately. And I will say, looking at like this particular problem right here, if I wanted to get a much better estimate of what's going on, I can see that somewhere between 0 and 3 is where this x value is, or where these x values are. So I can actually go in to Windows, set the X scale 0 to 3. And then Y min, I don't know, let's say -5. Oops. So have to put negate 5 to, let's say, +5. Now now that I've got it really zoomed in, does it make it a whole lot easier to figure out where that line is? Where that line is? And after you've graphed it and you think you've got an answer, come on up and let's see. And also remember to turn in the graphic calculators when you're done. I've got other students that are going to need to borrow. What you get. That's what you get. Oh, your name's on there?
Yeah.
So, one I got in charge at home.
Yeah.
Yeah.
Yes.
So we had the graph, is that?
Yes. That's what valid is.
Oh, like for options.
Yeah.
Correct. Option.
Yeah.
It's kind of hard to think about graph. That's very cool.
But we're just looking at it approximately. So.
Yeah, sure.
That's right here. Now, and straight fives. Yeah, we got +5. Pictures. Nah. Nah. Well, yeah. Two -4.
Negative, yeah, this makes so much great, because it was both lines and both sides. So it's. But it would have been negative, it was in front grade. So I can't really tell.
Well, we can actually plot it in here. So 2x -1. And then down here, it's supposed to be 5. So there's going to be a positive value. And I need to redo this. Say negate 10 to +10. So you can see -2 and a +3. All right.
I feel like my pre-calc teacher told me a lot of this, but it was kind of hard for me to understand because she was a language barrier and like she couldn't really explain it to us. And then she didn't know how to use the calculators or nothing. So it's kind of
Yeah.
explained a lot to me just from class.
Yeah. my goal here is to make sure that. Like when it gets to being you in real world. You're gonna be using your graphic calculator, you're using Excel, you're gonna be using software on that. So, I was used to it. This one says it's interesting.
Calculator. But nice to meet you. My name is Rocco.
Nice to meet you too. You guys make it too quick. See you next week. Have a good vacation.
These 4 years?
Gosh, it wasn't.
Alright.
Sure. Okay.
We were talking about. This is.
So, right, since there's a negative out there. So anything that's gonna be between the absolute values is gonna be positive. What positive number can you be negative for? There isn't. I was just talking about something. Yeah, it's.
I was like, I think.
Yeah, it's gonna be tricky. So. It would actually look to me legit, but that already. Okay. Because you've got the cosine is gonna be a full circle. Well, it's gonna be both sides.
So it should start on negative, even though it's absolute value,
Oh, the other one.
going down.
Pick it up.
Yeah,
It does.
okay.